Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have a 3D isometric projection of the solid, and using the information available in this 3D isometric projection, we are required to draw the orthographic projections, that is the front view, the top view, the left hand side view and the right hand side view projections over here. Now let us first of all evaluate the dimensions of the front view face, the top view face and the side view face over here. Now looking at the solid from the front, so we observe that the width of the solid happens to be 90 millimeter and the height of the solid, it is equal to 70 millimeter. So the dimensions of the front view face will be 90 millimeter by 70 millimeter. Now when we observe the solid from the top, so we observe that the width of the solid happens to be 90 millimeter, the depth of the solid happens to be 90 millimeter. So from the top view, the projections of the top view face will be 90 millimeter by 90 millimeter. Now looking at the solid from the side, so we evaluate that the depth of the solid happens to be 90 millimeter while the height of the solid, it is equal to 70 millimeter. So the dimensions of the side view face will be 90 millimeter by 70 millimeter. Now let us evaluate what are the different faces which will be observed by the viewer when the observer is going to look at the solid from the front, from the left hand side, from the top view and from the right hand side over here. So when the observer is going to look at the solid from the front, so there are three faces which will be visible to the observer. The first face which will be visible to the observer will be the face A, and this face A, it is an L-shaped face over here, and this face A, it will be parallel to the vertical plane. So the projections of the surface A which will be viewed on the vertical plane will be the true shape. Similarly, the second surface which will be visible to the observer will be the surface B. Surface B happens to be inclined to the vertical plane. Therefore, the projections of the surface B onto the vertical plane will appear as the apparent shape of the surface B. That is, the reduced shape of the surface B will be observed on the vertical plane over here. Then the third surface is surface E. So even though the surface E is directly not visible to the observer, it is lying behind the surface A. But this surface, it is a separate surface which is visible to the observer only when we assume that this surface happens to be transparent. So this surface E, this will be covered by the surface A. So that is why, so corresponding to the top face of surface F over here, we are going to get a dotted line over here, and this surface, even though this is not visible to the observer, but still it is a separate surface corresponding to the back portion of this vertical web over here. So that is why we have marked the surface as surface E over here. Now when the observer is going to look at the solid from the top, so the surfaces which will be visible to the observer, they will be surface B, surface I, surface D, surface F and surface C over here. Now surface B, it happens to be inclined to the horizontal plane, so the projection of the surface B onto the horizontal plane in the top view will be appearing as a shortened view. That is, the apparent shape of surface B will be visible to the observer from the top view. Similarly, surface I is there. Now this surface I, this is parallel to the horizontal plane. So the true shape of the surface I will be viewed by the observer in the horizontal plane. Similarly, you have surfaces D, F and C over here. So these three surfaces D, F and C, they also happen to be parallel to the horizontal plane. So therefore, the projections of the surfaces D, F and C onto the horizontal plane will reveal the true shapes of these three surfaces D, F and C. So when we view the solid from the left hand side, please check what we are going to see. So we'll be able to observe two surfaces over here. One is surface J and another one is surface H. Now surface J, it is this one. So this is my surface J over here. Now this surface J, it happens to be parallel to the profile plane. So the true shape of the surface J, it will be viewed by the observer when the observer is going to look at the solid from the left hand side. Similarly, surface H. So surface H, it is also parallel to the profile plane. So the true shape of the surface H will be viewed by the observer on the profile plane. But a part of the surface H, it will be covered by surface J while the observer is going to look at the solid from the left hand side view over here. So while we are going to construct the projections from the left hand side view, so we will find that part or the portion of the surface H, so this will be covered by the surface J over here. Then whenever the viewer is going to look at the solid from the right hand side, so we will observe that the other side, you see opposite side of the surface H over here, that is this side of the solid will be visible to the observer. So this surface H, which is not this one, it is lying on the other side of this vertical web. So surface H corresponding to the opposite side of the web, it will be visible to the observer 100%. So this will be drawn dark onto the profile plane, while certain portion of the surface J, now it is not this surface J, it is surface J which is lying on the other side of this inclined web. So part of the surface J, it will be appearing as dotted line or the covered portion compared to this surface H over here. So with this background, let us start with the construction of the orthographic projection. So in order to draw the orthographic projections, we need to draw the XY reference line and the X1, Y1 and the X2, Y2 reference line. Now the reason is because here we are going to draw the front view of the solid. Here we will be drawing the top view of the solid, and since we are required to draw the left hand side view and the right hand side view of the solid, so the left hand side view of the solid will be drawn on the right hand side of the front view, while the right hand side view projections of the solid will be drawn on the left hand side of this particular front view. When we have to draw the right hand side view and the left hand side view, so we need to draw the transfer lines over here so that the distances from the top view, they can be appropriately transferred onto the right hand side view as well as the left hand side view over there. Now let us start with the construction of the front view first of all, and we are going to draw the front view face, the top view face and the side view face on right hand side as well as on the left hand side view over here. So we know that the dimensions of the front view face, they happen to be 90 millimeter by 70 millimeter. So this is the width of the solid which is equal to 90 millimeter. This is the height of the solid which happens to be 70 millimeter. Now let us start with the front view. So in the front view we know that the width of the solid happens to be 90 millimeter. So we have left the distance between these two projector lines as 90 millimeter, and the height of the solid, it is equal to 70 millimeter. So we have marked the height of the solid, we have marked the width of the solid over here. So this 90 millimeter, please check, we have divided it into three parts. So as we are going to look at the solid from the front, so this inclined web, it is equal to 30 millimeter width. Similarly, this vertical web over here, the width of this vertical web, it also happens to be 30 millimeter. You see this intermediate well over here, this width will also be equal to 30 millimeter. Now we have drawn the vertical projector lines over here extending onto the top view over here. Similarly, this height of 70 millimeter, it has been extended onto the left hand side view as well as the right hand side view, because in the left hand side view as well as the right hand side view, the height dimension will be required in order to complete these two views over here. Now let us complete the depth of the solid in the top view. So we know that this is the depth of the solid. So depth of the solid also happens to be 90 millimeter. So we will be getting the top view face, it will be a square face in which the width, it is equal to 90 millimeter, and the depth of the solid, it is also equal to 90 millimeter. So once we have drawn the depth over here, so this depth we are going to project or extend into the right hand side view as well as the left hand side view. So using the transfer lines over here, this is transfer line number 1, this is the transfer line number 2. So using these two transfer lines, so please see, we have been able to transfer this depth of the solid into the right hand side view first and then the left hand side view over here. So in the left hand side view as well as the right hand side view, so we have got this depth of the solid, it is equal to 90 millimeter. Over here also it is equal to 90 millimeter. So depth of solid in the right hand side view, it is also 90 millimeter, whereas the height, it is equal to 70 millimeter. Now we have been able to plot the faces corresponding to the front view, top view, right hand side view and the left hand side view. Now let us start with the front view. So once we are looking at the solid from the front, so we are able to evaluate that these are the projections that we are going to get. So this is the height from the front, so this is the lower web, right? So corresponding to the lower web, the height of the lower web, it is equal to 25 millimeter. So I have drawn a projection line over here at a height of 25 millimeter from the base of the solid, right? After you draw this, now next thing is, please check, there is an internal slot over here. So this internal slot will be required to secure the solid onto base of any given slide. So then this slot will be required. Now this is an angular slot. So the height of this lower portion of the slot, it is equal to 15 millimeter. So I will be able to see a dotted line over here at a height of 15 millimeter from the base. So corresponding to this element, that is this angular element of the slot, so the height I know this is equal to 15 millimeter. So I have drawn again a horizontal projection line having height, it is equal to 15 millimeter from the base. So I will be able to identify this particular edge which is not visible to me. So it will be visible to me as a dotted line or a hidden line in the front view. Now the next thing is this slot corresponding to the surface F. So this is a vertical web which is having a U shape, and in this web I am going to get this slot over here, right? So this is a slot which I am having. So I know that the surface F, it is going to be located at a distance of 45 millimeter from the bottom or 25 millimeter height from the top. So now I am going to mark this height, it is equal to 45 millimeter from the base. Okay, so this is 45 from the base, or even I can mark it equal to 25 millimeter from the top. So I have marked this dimension with a lighter color because later on I am going to remove these dimensions which are shown with the orange color over here. So I have drawn this because in the side view I will be showing you this particular slot. So only to have a better understanding regarding the dimensions of the slot, so we have shown the distance of 25 millimeter from the top. So with this we have been able to project all the edges corresponding to the front view in the orthographic projections. Now what we are going to do, we are going to join the edges which will be visible to the observer looking at this object from the front side. So when the observer is going to look at the solid from the front side, so this base is visible, please check. This is the base which is visible. Okay, then this height 25 millimeter plus this height 45 millimeter. So this inclined surface will be appearing, or this entire surface will be appearing like a rectangle over here in the front view. So the apparent view of this particular surface will be observed by the viewer in the front view. So I am going to see this vertical edge, then there is a thickness of 30 millimeter from the top or 60 millimeter from here. Please check. This is equal to 30 millimeter corresponding to the web B, and this is 30 millimeter width. It is there corresponding to the surface I over here. So 30 millimeter corresponding to the bottom of the surface or the web B, and this is 30 millimeter corresponding to the surface I. So I have drawn 60 millimeter length over here, and similarly I have drawn 30 millimeter side over here. Now this is the rectangular surface which will be visible to an observer while the observer is going to view the solid from this front side. So this is the web, which is a huge one over here, but it will be appearing as a shortened surface which is a rectangular surface over here. So this is the apparent shape of the surface B. Now while the observer is going to look at the solid from the front, so this is again another rectangular web which will be visible to the observer, right? So this is the surface A which is visible. So please check, this is the surface A, and surface A happens to be true shape. So the projections of the surface A will be true shape as it is obtained in the front view on the vertical plane, and corresponding to this surface over here there will be one dotted line over here at a height of 15 millimeter from the bottom over here. So 15 millimeter above the bottom we are going to observe a hidden line or a hidden edge. So it is this cut, and this cut is running through and through. It is going to run through the entire width of the solid. So we are going to observe a dotted line or a hidden line corresponding to this slot which is available in the bottom side of this particular solid, and over here corresponding to surface F, again a dotted edge will be obtained over here. So with this we have completed the construction of the front view. So this is my surface E, this one, but it is not visible to the observer. So this surface has been covered by the surface A over here. So this entire surface is my surface A. So this is my construction of the surface A, right? So this is the surface B. So surface B happens to be apparent shape. Surface E and surface A, they happen to be true shape over here. Now let us work out the top view of this particular construction. In order to draw the top view projections of the solid, we can observe over here there is this surface D of the solid. So surface D, it is having the depth, it is equal to 30 millimeter, and it is having the width equal to 30 millimeter. So width 30 millimeter we have already drawn in the front view. Now the depth equal to 30 millimeter I have drawn over here. So please check, this is the depth corresponding to the surface D. So surface D is having depth equal to 30. So I have drawn the depth of this surface equal to 30 millimeter. Similarly, there is surface C over here. So surface C is also having width is equal to 30 millimeter. So this width equal to 30 millimeter I had drawn in the front view. So this is the width equal to 30 millimeter, right? So now the depth 30 millimeter I have drawn in the top view over here. So this is the top view. So the depth of the surface C will be observed as 30 millimeter over here. The moment I draw these two projection lines, so please check the true shapes of the surface D. This is the true shape of the surface D, which is a square having an edge equal to 30 millimeter. This is the true shape of the surface F, which is having the edge again equal to 30 millimeter. This is the true shape of the surface C, which is having an edge equal to 30 millimeter, right? This way, and again this is the flat surface corresponding to the surface I. So please check, this is the flat surface corresponding to the surface I. So this is also a true shape which has been obtained. And this face B, so please check, this face B, it appears as a shortened view in the top view. So we are going to observe the apparent shape of the surface B, which is being viewed as a smaller rectangle in the top view over here in the horizontal plane. The projections of surface B have been obtained, projections of surface I have been obtained, projections of surface D, F and C, projections of surface D, F and C have been obtained. So out of these 5 surfaces, projections of surface B, they are apparent projections, whereas the projections of surfaces D, F, C and I, they are the true shape projections. So I am left with these 2 slots over there. So this is a slot, but there are 2 edges of this slot over here. So 2 edges will be observed on back side and 2 edges of the slot will be observed in the front side in the top view. But both of these edges of this slot, they will not be visible to the observer. So they will be observed as dotted lines over here. So dotted lines will be observed on this side. Dotted lines will be observed corresponding to the slot on this side. But let us first of all draw the projections of these 2 edges. You see, these 2 edges we have drawn over here in the top view. Now we have to now produce or extend these 2 projections in the side view. So on the left hand side, I have projected it over here. That is the projections corresponding to the surface D and the surface C over here. Similarly, the projections corresponding to the surface D and C, they have been projected onto the left hand side view as well. So both these projections we have projected. Now we are going to move on to these edges. So corresponding to the slot which is available at the bottom, we have got 2 edges on the back side and 2 edges on the front side. Now let us plot the edges which are available on the rear side and the edges which are available on the front side corresponding to this angular slot which is available at the bottom of this particular solid. Now we know that these edges, they are not visible to the observer from the top, so they will be drawn as dotted line projections in the top view over here. Now let us have the locations of these 2 points which are lying on the rear side of the solid over here in the bottom orientation. So I know that this distance, it is equal to 25 millimeter. So corresponding to 25 millimeter from the rear side. So please see, this is the rear face of the solid over here. This is the rear face of the solid. So from the rear face, if I move forward by 25 millimeter, I'll be able to obtain the bottom point of this slot. And in order to obtain this angular portion, I know that this dimension, it is equal to 60 millimeter, while the base dimension, it is equal to 40 millimeter. So it means that since this dimension is 40, this dimension is 60, it means that you have to move back by 10 millimeter on this side and move forward 10 millimeter by this side, so that these 2 top corners of the slot, they can be obtained. So what we are going to do, if this distance happens to be 25 millimeter, so the distance of the top portion of this angular slot will be 15 millimeter from the rear face. Similarly, if this point happens to be 25 millimeter towards the back side, so this point which is lying on the top face of this slot over here, this will be lying 15 millimeters behind the front face of this particular solid. So with this information, now I am going to draw 2 projection lines over here which are going to represent this point which will be 25 millimeter from the rear face, and this point which will be lying 15 millimeter from the rear face over here. So this angular portion, it is going to have the depth equal to 10 millimeter over here. Now let me see, I have drawn first projection line at a distance of 15 millimeter from the rear side, and another projection line I have drawn at a distance of another 10 millimeter from this edge over here, so that the total distance from the rear edge becomes 25 millimeter. So again I repeat, the distance of the bottom point of this particular angular slot, it is equal to 25 millimeter from the rear end. This is 25, and the distance of this top point of this angular width, it happens to be equal to 15 millimeter from the rear end over here. And the height, we have already discussed, height of this angular slot, it is equal to 15 millimeter, which we had plotted in the front view. We have plotted these two locations corresponding to this point and this point over here. We are going to transfer these locations onto the side view, and please check this out. This is a point. I told you that the bottom point is located onto the base. So this is the bottom point, will be at a distance of 25 millimeter from the rear face or the rear end of the solid over here. So this is 25 millimeter from the rear end, and once I projected onto the side view, I am not going to extend it to the top because this point will be lying onto the bottom over here. Similarly, as I move to the left hand side view, so this is my distance of 25 millimeter from the rear face, and then as I project this projection line onto the left hand side view, I am going to project it only up to the base because I have represented this bottom point of this angular slot. Now let me talk about this top point of this angular slot. It is this point. It is at a distance of 15 millimeter from the rear face or the rear end of the solid. Now this is the projection line which I had drawn corresponding to the upper portion of this particular slot over here. Now if I project this projection line onto the side view, so I am going to project it up to a height of 15 millimeter because we discussed that the height of this point from the base, it is equal to 15 millimeter. So I have projected this on the right hand side view up to a height of 15 millimeter only. Similarly, if I project this top face of the slot on the left hand side view, again this will be projected up to a height of 15 millimeter only. Now same thing I am going to do from the front end. So from the front end, this is my front face. Now this top portion, it will be at a distance of 15 millimeter from the front face A, and this bottom point of this angular slot, this will be lying at a distance of 25 millimeter from the front face onto the base over here. Now I have drawn, please check, two lines over there, two projection lines. They have been drawn. This line has been drawn at a distance of 25 millimeter, this one, and this projection line has been drawn at a distance of 15 millimeter. It means onto this projection line, my top point of this angular slot will be lying, and onto this line which is lying at a distance of 25 millimeter from the front face over here, this point, I am going to locate the bottom point of this angular slot corresponding to the front face, right? Now let me transfer these two projection lines onto the side view. So whichever projection line, it is at a distance of 25 millimeter from the front face onto this line, my bottom point of the slot will be located. Please check. The bottom point of the slot has been located over here. Similarly, on the left hand side, so this projection line, it was at a distance of 25 millimeter from the front face. So onto this line, my bottom point will be located over there. This is the bottom point. And similarly, whichever horizontal projection line was drawn in the top view at a distance of 15 millimeter from the front face, onto that particular line, I am going to locate over here the point which is lying at a distance of 15 millimeter from the base. That is, this point of the angular slot on the front side will be located. Similarly, over here we can see that on this side I have to locate this top point of this angular slot. It is this point or it is this point over here. So both of the points of the bottom and the top, they have been located corresponding to this bottom angular slot in the right hand side view and in the left hand side view. And we can check that corresponding to the base, the distance happens to be 40 millimeter between the two base points of the slot. Please check, this is equal to 40 millimeter. And corresponding to the top points of the slot, the distance happens to be 60 millimeter. So this distance corresponding to the top points of the slot will be 60 millimeter, right? Similarly, on the right hand side also we have plotted the top points. They are separated by a distance of 60 millimeter at a height of 15 millimeter from the base. Similarly, the bottom points of the slot, they are located at a distance of 40 millimeter from each other. This is 40 millimeter at the base. So now we can join these slots over here. Please check, the angular slot has been joined in the left hand side view as well as in the right hand side view. So another thing we can locate over here, this is the slant edge which starts from this top corner and it goes up to a point over here. When we are going to look at the solid from the left hand side view, we can check at the back we have the highest distance over here, and at the front this slant edge will be located at a distance of 25 millimeter from the base. So at the back we are going to get the height which is equal to 70 millimeter, and at the front we have the height of the sloping section B which is at a height of 25 millimeter on the front side face. So we can join this inclined edge over here like this. Whereas when we are going to look at the solid from the right hand side, so we will find that at the rear edge this slope is highest. So while we are looking from this side, so at this edge, this is my rear edge. Please check, this is my rear edge. So at the back side, so at the rear edge, the height of this particular face, it will be highest at the rear edge, and at the front edge the height of the surface B will be equal to 25 millimeter. So please check, this was my rear edge. So over here the height will be 70 millimeter, and over here the height will be 25 millimeter. And now I have been able to obtain the projections corresponding to all the edges of the solid. Now I am going to start with darkening of the edges which are visible to the observer. So in the top view, please check, this whole square, this will be visible to the observer. So please check, this surface as well as this surface. So this surface and this surface, they will appear in a single straight line. I have drawn a straight edge over here. Similarly, this surface and this surface 90 millimeter, again they will be viewed as a single straight line. Similarly, this surface of the well and this surface corresponding to the inclined web, they will be appearing as a straight line. And this surface, though it is inclined, it will be appearing as a straight edge in the top view. So this boundary has been darkened in the top view. Now we have already discussed that this is the rectangular face which is inclined. So from the top view, the surface B will be appearing as a shortened rectangle. So this surface, it is a bigger surface, but it is inclined with respect to the horizontal plane. So this surface will appear as apparent shape or the reduced shape in the top view. Now next one, once I draw this edge over here, now this edge has been completed over here, and then once I am able to darken these lines at a distance of 30 millimeter, this is 30 millimeter from the front and this is 30 millimeter from the back. Now I have been able to obtain true shapes of the surfaces D, F and C over there. This is surface D, surface F and surface C over here. And similarly, surface I true shape has also been obtained. Now I need to obtain the dotted lines corresponding to this top portion of the angular slot and the bottom portion of the angular slot on the rear side as well as on the front side. So 4 dotted lines, they will be observed from the top view, 2 corresponding to the rear angular edge over here, and 2 dotted lines will be available corresponding to this angular edge which is there on the front. Now here we are going to draw the dotted projection lines corresponding to the bottom face as well as the top face of this angular slot. So please check. So this is the dotted line corresponding to the top edge of this particular angular slot, and this is the dotted line corresponding to the bottom edge, this one, of the angular slot which is available on the rear side. Similarly on the front side, so here we have this distance is 25 millimeter. So this is the bottom edge over here of the angular slot. So this is the dotted line corresponding to the bottom edge of this angular slot, and similarly this is this one, the dotted line corresponding to the top edge of this angular slot. So this completes the construction of the top view of this particular solid. Now let us place different faces over here. So this is face B, which is apparent shape. This is surface I, D, F and C, which are the true shapes of the surfaces which are represented in the isometric projections over here. Let us now evaluate the projections of the solid as they are viewed by the observer from the left hand side. So from the left hand side, please see, the observer will be able to view this angular slot. So this angular slot will be visible to the observer as an object line or as a dark line. Then from the front view, please check, this vertical edge will be visible to the observer. So this has been drawn using the object line. Similarly, this vertical edge and this portion of the vertical edge, they will be visible to the observer as a single straight line, right? So they are going to be appearing as a continuous line from the left hand side onto the profile plane which is located on the right hand side. So this vertical edge will be visible to the observer from the left hand side view. Then when the observer is going to view the solid from the left hand side, so one thing we are going to see, because this is a sloping area, please see, this surface is sloping. So this horizontal portion of the web edge over here, which is a vertical web, this will be visible to the observer. Similarly, this portion, it is visible to the observer, and whatever portion of this, please check. So here we have a rectangular slot which is having this rectangular slot, it is having the depth equal to 30 millimeter and height, it is equal to 25 millimeter. So whatever portion of this rectangular slot goes behind this slant edge over here, this portion will be appearing to the observer as a dotted line, whereas the remaining portion of this rectangular slot will be viewed by the observer as an object line over here. So this will be visible to the observer. So this inclined surface corresponding to the surface B, this will be visible to the observer, and this slant edge, right, this slant face corresponding to the surface J over here. Please check, this is my surface J. So this surface J, it is going to partially cover the surface H, right? So whatever portion of the surface H will be covered by the surface J, that will be drawn as a dotted line. So this portion will be drawn as a dotted line over here. So this portion will be drawn as object line, whereas this will also be dark, and this portion will be appearing as a dotted line. So please check this portion of this rectangular slot. So this portion of this rectangular slot will be viewed by an observer as a hidden line, whereas rest of the solid which will be available as surface J, this will be visible to the observer as the object line, right? So these are the projections of the solid. And then please check, we see that this portion of the well which is corresponding to the surface I, this portion of the well over here which is corresponding to the surface I, this is not visible to the observer from this side. So we are going to get a dotted line at a height of 25 millimeter above the base of the solid. So above the base, please check, this is the height of 25 millimeter. So this well will be observed as a dotted line in the left hand side view. So this completes the projection of the left hand side view. So this is the surface J, please check, this is the surface J which is parallel to the profile plane. So the true shape of the surface J has been obtained. Similarly, this is the surface H over here, and this portion of the surface H, it is not visible to the observer, so this has been drawn dotted, but this was the boundary. So this boundary, it is going to cover this boundary over here. So that is why this dotted line has been covered or overshadowed by this object line corresponding to this inclined web over here. So that is why this portion has been drawn as a dark line, right? So these are the projections of the solid which are observed from the left hand side. Now let us project it from the right hand side. When the observer is going to look at the solid from the right hand side, the observer will be viewing that, once again, this slot will be visible to the observer from the other side as well, because this slot is going to run through and through the entire width of the solid. So this is the entire width of the solid, 90 millimeter. So this slot will be visible to the observer even from the right hand side. And then the vertical edges, they will be visible to the observer. So this vertical edge, observer can see from the right hand side. This vertical edge, again the observer can see from the right hand side. And this rectangular slot which is available over here, so this rectangular slot will be visible to the observer. Now you can see, now the priority has to be given to this slot over there, because this vertical wall is visible to the observer from the right hand side. Now because the observer is going to look at the solid from this side, so certain portion of this inclined web will be visible to the observer while the observer is looking from the other side through this slot. So through this rectangular slot, so whatever portion of this web is visible to the observer, this will be drawn as a dark one, whereas the remaining portion of this inclined web which is covered by this vertical wall over here, this will be drawn as a dotted surface, right? So this is the dotted surface. And similarly from the right hand side as well, this well surface, it is not visible to the observer. So at a height of 25 millimeter from the bottom, again another dotted line will be drawn over here. So this completes the projection of the right hand side view of the solid. So this is the surface J, this is the surface H over here. So we can distinguish between the left hand side view and the right hand side view. In the left hand side view, priority has to be given to this inclined web. So whatever portion of this vertical web it goes behind this inclined surface will be drawn as dotted over here. Similarly from the right hand side, priority has to be given to this vertical web over here. So vertical web we have drawn as dark, and whatever portion of the web, that is this inclined web, it goes behind this particular vertical web over here. So this portion will be drawn as dotted lines over here. So this is the complete construction of the orthographic projections of the solid, and we have drawn both the right hand side view as well as the left hand side view for this particular solid over here. Now let us remove the extra surplus dimensions or the redundant dimensions which were drawn only to improve the understanding of the construction over there. So please check the height we have removed over here because it is already mentioned as 45. So the remaining dimension was given as 25 millimeter over here. So since these dimensions they were mentioned over there in the depth view, that is in the top view, so only repetition is lying in the right hand side as well as in the left hand side view. So these dimensions again we are going to remove, and finally we are going to remove these markings regarding the different faces of this particular solid which are visible to the observer from front, top and the side view, so that the better interrelationship between the isometric projections and the corresponding orthographic projections can be obtained. So I hope that with this discussion you will be able to understand in a better way how to develop the orthographic projections of the solid when the isometric projections of the solid they are available with us. So this is all for today. So we'll be continuing with few more applications of the orthographic projections in the coming lectures. So thank you very much. Thanks a lot.